Hello everyone, welcome back. This is another tutorial in continuation learning about machine learning, artificial intelligence, different concepts related to it. Okay, we saw what is neural networks in previous lectures, in previous videos. Let's have a quick reminder. What is a neural network? I mean, a neural network, it is like a computer program which is inspired by the human brain. What you have is inputs in the form of neurons, which are nothing but numbers. They are connected to neurons in other layers, which we call it as hidden layers. And finally, they give us some output, or rather predict some outputs. And in a neural network, every node is connected to every other node. And each of this connection is called a weight and it has some value. So data flows from here to here, here to here, here to here. And how it flows is based on the activation function, which we have discussed before, which is ReLU activation function, sigmoid activation functions, some activation functions which will trigger the neuron, which neuron gets activated. And then ultimately, the model predicts some output. If the output is not what we expected, we do back propagation, okay, which is also which I explained it in the gradient descent video, okay. So which means what we do is we go back, adjust the weights, and then again see if the output is right. So this back and forth goes on. That's neural network. The problem with neural network is it does not remember the context. It treats each input independently. So, say for example, here, if these are words of a sentence, it will treat each word independent of the other. But when we are actually talking, we make sense of a full sentence. Our brain makes sense of a full sentence. It's not just one word. Like, say, for example, I am going for a movie. So it's your brain will process the entire statement and then come to a conclusion, okay, she is going for a movie, right? But it's not like your brain is processing each word separately. It will remember the context. When I say I am going, so which means you will associate going to the movie with me. Okay, that is context remembering. So neural networks lack that ability, okay, that it forgets. So if we ask a regular neural network to guess the next word, I have a black, it could be a jacket, a cat, anything, but it cannot use this information, a simple neural network, to predict the next word. But now when we talk to any LLM, whether it is ChatGPT or whether it's Gemini, any neural network which we talk to, right? It can talk to us back like a human. Okay, it can what do you say? Understand the context in which we are asking the question. Okay, which means it knows how to make sense of it. Okay, how it does that? That's where the RNNs come into play. Okay, RNNs are neural networks, but with the ability to remember what it has learned so far or what it has seen so far, which means it does not see each word independent of the other. So it knows the context. Okay, so the key idea is that RNN have memory. Okay, which means now in simple programming language, if you're familiar with any object-oriented programming language, what it does is the weight of each learned or the hidden state, which we're going to see later, that it learns of each word, it is stored in some form of a variable within the RNN's code, whichever is there. Okay, so it's like, think of it as a reading a book. You remember what you read in the previous chapters to understand the current chapter, correct? Now, so which means every step at a particular time t, it remembers what it had learned in the previous words. So let's see a step-by-step overview. Now this is, we will have a very detailed step-by-step overview also, like an example in the end, okay? So what we do is, at each step, RNN receives a word, okay? What it does is, it combines it with the previous hidden state or its memory. Initially, it just assumes any random weight, and then it updates as the time flows by. So this is the hidden state at time 0, hidden state at time t minus 1, hidden state at time t, hidden state at time t plus 1, okay? Which means if this is the correct current time, it remembers what was the hidden state at time t minus 1. Using that information and the input that it receives, it computes the hidden state value of the next one, okay? And y hat is the prediction, and O is the weight at that particular time of the input, okay? So what happens is, hidden state updated, f is nothing but an activation function. What it does is, the weight of the input at that time t plus the weight of the hidden state of the previous word, whatever it has learned, okay? And then it computes the final output. Here is the output, okay? So each one is kind of mini neural network, okay? It gets its input, computes the hidden state using the previous one. First one, it just assumes randomly something. And then at the end, if the output is not correct, again, the back propagation happens and it goes on adjusting it. So it keeps on redoing it. So that's why it's recurrent, okay? Keeps on doing it again and again, again and again until it is trained. So F and G are activation functions. This is the sample formula, what it uses. The activation function of which neuron or what height it has to be is, again, the weight times the input at the time t plus the weight of the hidden state of the previous word. Where is RNN used? RNN is used in language translation. Some examples, practical implementations, okay? So converting from English to Spanish or English to Portuguese or any other language, okay? So RNNs can read the whole sentence, understand its meaning, and then convert the entire sentence into another language, okay? It can also be used in speech recognition, okay? Again, it involves a process of spoken words into text, okay? What it does is, when you speak, it converts it into a text. So they can analyze the audio signals over time, identify the sequence, okay? Like the basic sounds that each word make, like the, cat, mat, okay? So it makes a unique sound. Each word makes a unique sound. So it learns over a period of time. And its practical implementation, thinking of like Siri, Alexa, Google Assistant, you just say, hey Siri, what's the time? Or hey Alexa, what's the time? So they know what you're saying, correct? They understand your voice commands. So what in turn what is happening is, they take each word, determine its phonetics, okay, go it through the audio wave, goes into it, goes through a spectrogram, then there is CNN or RNN, then goes into feature maps, and then it goes to long short-term memory architecture. This is our RNN. This is one form of RNN. Okay. So let's see an example. Okay, step by step. So basically, what we have learned so far, or what we know about RNN, is that it understands the whole sentence. How it does that? Let's see. So simplified sentence, okay? So we'll focus on the key concept and the flow of information without going too much into or without diverging too much into technical details, okay? So imagine we are teaching RNN to predict the next word in a sequence, okay? So first we need the data for any training, any machine learning thing, right? You need the data. So let's use a tiny vocabulary. So the cat sat on mat, okay? So this is our vocabulary and a dot like a period. So we assign the each word, we assign it an index value. So the is 0, cat is 1. It doesn't matter what value we assign. We assign values to it, okay? So our training data, the cat sat on the mat, and again we reuse the same sentence, okay? So what is the task? Given a sequence of word, predict the next word. Okay, so we'll have a simple RNN with a hidden state of two hidden states. Okay, like like how neural networks have hidden layers, like that. It will have two hidden states. Okay, which are initially assigned some random values. That's how any neural network works. First, it does starts with a random value. So first sentence, the cat sat. So the is at input 0. So the RNN receives the word. It combines this input with its initial hidden state, which is right now it's 0, which is random because the first word. Then RNN calculations using its current weight produce a new hidden state. Okay, so let's say the new hidden states computed are 0.1 and minus 0.2. It's just random right now. So now this hidden state represents what RNN has learned from seeing the. Okay. One thing you must know about any artificial intelligence, machine learning, any model, anything, everything at the end of the day comes down to numbers. Okay. Once ChatGPT itself told me that when you're talking to ChatGPT, you're talking to billions and billions of numbers or hidden matrices or matrices of numbers. Okay, so it's all ultimately numbers. Now, RNN also makes a prediction here. So let's continue our example. It outputs the probability distribution over the vocabulary. So initially, everything is random. Okay, so let's say it predicts cat with the probability of 0.1 and sat with the probability of 0.2. Now, step 2, it reads the word cat. Okay, it combines this input with the previous hidden state. So this was the previous hidden state, okay, 0.1 and minus 0.2. Okay, it is the memory of seeing the word the. Now it computes the new hidden state using the weight of the word cat, okay, and let's say assume the new hidden state when it learned cat is 0.3 and 0.0. So it makes a prediction for the next one, which is also first time. It's just random. Okay. And now the third word comes in, sat. Okay. Now it receives sat. It combines this with the previous hidden state. Now it calculates the new hidden state. Now the new hidden state, again, we saw the formula before, right? Using the weights, and it makes prediction for the next word. Okay. And now it receives the full stop or the dot, and then it combines with the hidden state, calculates. So this is how it goes on. Okay, so the calculating the loss and backpropagation, which means if the word predicted is not what we expect, then we calculate the loss and go back and change the weights. When we change the weight, the hidden state value also changes. because the weight, the hidden state, like we saw here, changes as the weight changes. Okay. Now, same thing goes on when it receives the next word. Okay. Now here, back propagation through time, we calculate, we use calculus to figure out how to adjust RNN's weights to reduce the loss, and then the it goes backward, changes the heights, changes the weights, and then calculates again, and again calculates the loss. It goes on and on. Now the second sentence came in. Let's see, the cat, this is the second sentence in our training data. The cat sat on the mat. So we repeat the same steps. First, it will learn the, compute its hidden state, then it will read cat, then compute the hidden state using the value what it has learned with the, and then sat, compute a new hidden state using the value what it has learned with cat. Like that, it will go on with each word as it keeps on learning, keeps on learning. And this process just goes on and on and on. So just to revise what we have learned so far, the problem with regular neural network is that it processes each input independent of the other. It does not understand the context. So therefore, it's just simple neural network is not good for developing LLMs or large language models, because when we speak or when we talk, it's an entire sentence, which means all the words are related to each other. So we need a model or a kind of algorithm which does not process each word independently, but instead remembers what it has learned previously and use that learned information to predict what could be the next sentence. Okay. So it learns it, learns this, compute the hidden state, and make predictions. So again, like any other learning algorithm, first it assumes random weights, goes on all the way to prediction. And if we see, oh, no, the prediction is wrong, change the weights, go back, come back, learn again. So this process goes on. Practical applicability, it is used in language translation. It is also used in speech recognition. Okay, so these are some usages of RNN. Now this is again, it's explained in a very, very, very simple terms of what it is. Okay. In real life, it does not um, read the whole word, but instead it's embedded word. It's a vector actually. The word is typically converted into a vector, which is called as embeddings. Okay, and this allows RNN to learn the relationship between words. We'll cover embedding in another video, but for now, just understand that RNNs are more advanced than simple neural networks in a way that they have some memory, which means they can store information about the previous word that they have read in the sentence in their learning algorithm, okay, or in their learning stage. All right, that is all. Hopefully, you understood what is RNN. In your mind, it is clear. Feel free to like, subscribe, or if you have any questions, feel free to comment. Thank you all. See you all again in next lecture. Okay, hopefully you remember me. Okay, but before I let you go, a simple joke, because we were talking about RNN and how these what you call large language models learn and talk to us. I had perplexity tell me a joke. Okay, I just told perplexity, tell me a joke. Okay, here is the joke what it told me. It said, why did the, let me open it. Okay. Why was the coffee? Oh, no, no, sorry. The joke is, Why did the coffee file a police complaint? Okay. And the answer it gave me, because it got mugged. Okay. All right. So this is RNN again in real action. Hopefully you like it, enjoy it. Okay. Thank you all for your time. See you all next time. Bye.